Imagine a robot that never gets confused, no matter what input you give, and it also knows the next move that it follows. That's what exactly a finite automata do. Yes. Hey learners, I am Soundarya and this is your study zone. Today we are going to explore about the formal definition of finite automata and simpler ways to specify a DFA and then some of the problems in DFA. So let's go through them one by one. Okay, now what is finite automata? A finite automata is an abstract machine with a mathematical model. So remember this one, which has an mathematical model. Okay, so which means mathematical model of computation. Okay, so FA is an abstract machine which has a mathematical model. A mathematical model is of computation. So there are certain symbols used in FA. So the first symbol is circle with Q0, correct? So a circle is used to represent a state. Okay, so if anything, like if A is with circle or B, or let's take it as Q5, if anything is enclosed with circle, then it is called as state. Okay, and then here this is state. This state is here, but it has an extra thing, that is arrow, correct? So circle with an arrow represents an start symbol, which means if there is a arrow here, then it is a start symbol. Okay, and then for this circle there is another one circle here, right? So state is Q0 and there is circle, and if there are two circles are used to represent final state. So here Q0 is the final state. Okay, so if the circle with arrow, then it is a start state. So if the state with two circles, then it is a final state. Okay, and then we have two states here, correct? So state Q0 and state Q1, and then upon arrow we have 1. So what does it mean? This indicates that there is a transition from state Q0 on input 1 to state Q1, which means when we have an input of 1, then there will be transition from the state Q0 to Q1. Okay, so this is the transition function, correct? So the transition from one state to another state is transition function, and it is represented by delta. This is the transition function of Q0 on consuming or upon the input of 1, it will move to Q1. Okay, so these are all the symbols, and the next symbols are, so the next symbol is Q0 on self loop with 0, correct? So here we have self loop with 0. So here what does it mean is, upon consuming 0, machine remains in same state, which means upon consuming 0, it will be in the same state, that is it is at initial. Okay, this indicates that machine state Q0 on reading a 0 remains in same state Q0, which means delta of Q0 comma 0 will be there in the same state, that is Q0. Okay, and then we have another symbol, that is Q0 with two inputs here, that is 0 comma 1 will change to the next state, that is Q1, which means upon consuming 0 or 1, machine moves from Q0 to Q1. It may consume 0 or it may consume 1. So upon consuming 0 or 1, it moves to state Q1. Okay, so here we have two transition function, correct? So delta of Q0 comma 0 will be Q1, and delta of Q0 on 1 also equals to Q1. So these are all the symbols that is used to represent a finite automata. Okay, so the next topic is simpler notations used to specify DFA. So there are two notations using DFA can be easily represented, and they are transition diagram and transition table. So let's first discuss first one, that is transition diagram. Okay, so what are the two notations used to represent DFA? Yes, tell me. First one is transition diagram, and what is second one? Second one is transition table. So what is transition diagram for DFA? This is the common thing. I hope you watched the previous video. On that we have discussed about one of the example for DFA, correct? So that is the transition diagram. So transition diagram for DFA is M equals to Q comma sigma comma q naught comma delta into comma f. So what is q here? Yes, q is state. What is sigma here? Sigma is an alphabet. What is q naught? Q naught is a starting state, and delta is a transition function, and f is the final state. So E is defined as a graph with circles and arcs with labels, two circles, etc. So this is a transition diagram. Okay, so here look here, transition diagram is a simple transition diagram. So here we have arrow, circle, and here there is a self loop which has an alphabet 1, and we have a state q naught. So these kind of representation, or it might be like this, q naught. So it might be like this, q naught, which might goes to q1, which might goes from q3, and then from q3 to q4. So this is also an transition diagram. Okay, so let's see what is transition table. Now you are clear with transition diagram, right? Transition diagram is something we used to define with the help of circles, arcs, and labels, and two circles and arrows. Okay, so this is transition diagram. Okay students, next is transition table for DFA. So M equals to Q sigma delta Q naught F is tabular representation of a transition function such as delta takes two arguments and return a value, which means delta take two arguments and then it will return a value. That might be a new state, correct? So the rows of a table, so it is a transition table, correct? So the rows of a table corresponds to the state of DFA obtained from Q. What is Q? Q here state, right? So I will write it here. Here we can write it like rows A, B, and then C. Okay, so the rows are obtained from Q, correct? So next we have the column correspond to the input symbol obtained from sigma. So what is column here? So here we have column that corresponds to the input symbol that is obtained from sigma. Remember this one? Here we are building a tabular structure. So in the table we have rows. The rows is from, what is the rows? Rows of a table corresponds to state of DFA, and columns corresponds to input symbol from sigma, and we have the initial state marked with arrow. So here let's take this as initial state. So this is marked with arrow. Okay, and then we have final state marked with star. So what is final state? Let's take this as final state. It is marked with star. Okay, and then delta of q comma a will be, here q is the current state and a is the current input symbol. So let's take here, let's solve this. Okay, so here q is the current state and a is the current symbol, right? So a, by taking the input symbol small a, let's take it will goes to new state b, and then a on input b, let's say it goes to new state c, and b on a, let's say it goes to a, and b on b itself, let's take it as b itself, and c on a, it might go to a, and c on b, it might goes to b. So this is transition table. Is it clear? Yeah, so let's move to the next topic. So now let us solve some of the problems on DFA. Okay, so here the first question is, write DFA to accept 0 or more A's, which means clean star, correct? 0 or more A's. So at first, remember this one, at first what we have to do is we have to write languages that are there here. So how to represent 0 in DFA? Do you remember? So 0 can be represented using epsilon, and 0 or more A's, which means any number of A's. It can be 1A or 2A or 3A, so on, correct? So here at first we have to write languages, and then we have to write a symbol here. So here symbol is used only one, right? That is A. So now here we wrote languages and symbols. Now we have to write DFA, which means transition diagram and transition table. So if here it is 0 or more occurrence of A, so we can write it like Q0. So this is one state. Since it is 0 or more, how we can write is, this is the initial state and this is the final state, and here A. So at first it will be here only, right? Let's take at first robot is here only. So here if it not consume anything, it will be there in this state only. So it doesn't consume. So there is one chocolate here. If it doesn't consume that chocolate, it will be in state Q0 only. So 0 occurrence is done. And then if it consumes some chocolate, so let's take it consumes 3 chocolates. So it will be like one chocolate, A is done, one chocolate, A is done, another chocolate, A is done. It will be there in this state only. So this is how we represent transition diagram. Is it clear? This is 0 or more occurrence of A. Okay. So next we have to write the transition table, correct? So Q0, there is only one state here. So write only Q0. Upon taking the input A, it will be there in the state Q0 only, correct? So Q0 only, and then we have to represent it with arrow and star, both. Is it clear? So let's move to the next one, then it will be clear for you. So here write DFA to accept 1 or more A's, which means clean plus, correct? So at first what we have to do? We have to write languages. So L equals to, shall I write epsilon here? No, right? Because 1 or more A's. So A, any number of A's, correct? A, so on. So here we need at least one A, correct? So here we need, here if we wrote like this, then we can have 0 number of A also, but we need at least one A here. So there should be a transition, correct? So Q0 on consuming A, it should move to next state, and that state is a final state, correct? So Q0 on consuming A, it should move to final state. This one is done. Now Q0 has A, so it is getting A and then it is moving to final state. Now if it gets another A, it should be there in final state only, clear? If it gets only A, it is moving to final state. So the string is accepted. If it get 2A, then it should move to final state, and if it get another A, it should be there in final state only. If it is A, so it should be like Q0 on A, it is moving to final state, and then we have A left, correct? So it should be A in final state only, done, and then A final state only, done. So the string is accepted, clear? So for our problem, for this string to get accepted, we have to write the solution, okay? And then we have transition table. So here we have how many states? 2 states, correct? That is Q0 and Q1 upon consuming A. So Q0 on A, it will move to new state, that is Q1, but Q1 on A, it will be on final state only, that is Q1 only. So initial state, final state, clear?